Okay, this video is to get you guys going on the bonus for the fall exam. Now, you need some information from problem number 8 on the test that you took this morning. The information that you need from it is that you have two reactants, silver nitrate, 60 milliliters of 1 molar solution, and you need to know that that's reacting, and this is aqueous, of course, and it's reacting with sodium chloride, aqueous, 25 milliliters of 0.80 molar. So these are your two given, and since they are both reactants, that means that, of course, this is a limiting reactant problem, which you found in number 8. So you've got to have a balanced chemical equation, and then from that balanced chemical equation, you need to use your limiting reactant to find grams of precipitate is what you did in number 8. In the bonus, you have to find moles of the excess ion in solution. Then you have to find the concentration of that excess ion in solution. And remember, concentration is moles per liter of solution. And then find the concentration of each spectator ion in solution. So I'm going to work a different example in this video so that you'll see how it's done, and you can apply this to the bonus tomorrow. Okay, so I'm going to work a problem out of the Zoom doll, and I've kind of added to it to show you what to do with the bonus. We're going to take aluminum nitrate, an aqueous solution, and react it with potassium hydroxide. We have 0.2 molar aluminum nitrate, 50 milliliters, and we have 0.1 molar solution of KOH, 200 milliliters. Okay, we are going to find moles of excess ion remaining in solution. We're going to find concentration of the excess ion remaining in the solution. That means after the reaction is complete. And the concentration of each spectator ion. In solution. Okay, so the very first thing that we need is balanced chemical equation. So this is double replacement. All precipitation reactions, which is what this is, are double replacement. So aluminum is going to bond to the hydroxide. Aluminum is a +3 charge. Nitrate is a -1. Potassium +1. Hydroxide -1. So when aluminum +3 bonds to hydroxide, we need 3 hydroxides to balance out the charge of aluminum. The other reactant, potassium, is going to bond to nitrate, +1 -1, that's just KNO3. Balance the equation, and we're going to need 3 of the KOH and 3 of the KNO3. Now, you need to decide which one is going to be the precipitate, which product. So remember from your solubility rules, a lot of times it's easier to figure out which of the products is remaining in solution. That's usually easier than figuring out your precipitate. Remember from the solubility rules, all group 1 are soluble. All nitrates are soluble. We got that right here. So KNO3 stays in solution. So by default, aluminum hydroxide is the precipitate. Hopefully, you'll know to do that in the test. Now, for this bonus, the next thing we need to do is we need to know how many moles of each reactant we have. Remember, molarity times volume in liters gives us number of moles. I'm going to erase some of the stuff down here so I have some room to work on this little board. Okay, so for the aluminum nitrate, we have 0.2 molar. We need that volume to be in liters. So we're going to change that to 0.05 liters. Over here, 200 milliliters will be 0.2 liters. Molarity times volume gives us 0.01. We're taking this times this to get 0.01. And I don't have my sig figs. I think I'm doing 3 sig figs on this. So 0.01 moles of aluminum nitrate. And on the KOH, 0.1 times 0.2 liters is 0.02 moles of KOH. Okay, going through the calculations to identify limiting reactant, which you would have to have already done on the test. Remember what you do is you take each of these reactants, convert it to your precipitate. Whichever one forms the least amount of precipitate is your limiting reactant. And I went ahead and had written this. I'm going to erase because we don't need that anymore. I went ahead and written out the ionic equation, which helps with this bonus because we need to know the ions in the solution. Once you dissolve these, these two reactant compounds, they're going to break apart, dissociate, and be ions in solution. So that's really what we need to be dealing with here. So let's do that first. Okay, ionic equation. You've got aluminum plus 3. We have nitrate. How many? 3. 3 nitrates. How many potassiums? 3. How many hydroxides? 3. This is a precipitate. It stays as a solid. This is in solution, 3 potassium, 3 nitrate. Now, I went through and did the calculations to identify that KOH was the, sorry about that. This is the limiting reactant. This is in excess. Once again, the way I figured that out, I took this 0.01 moles of aluminum nitrate, I converted it to moles of aluminum hydroxide, got that answer. Then I took the 0.02 moles of KOH, converted it 0.02 moles of aluminum hydroxide. I looked at the two answers, and the one that formed the least amount of aluminum hydroxide was the 0.02 moles of KOH, so that is the limiting reactant. That means it all gets used up. It's gone. You know, the part of KOH that is in the aluminum hydroxide. So, since that is limiting reactant, I'm going to label that on my ionic equation. Now, what part of that limiting reactant is tied up in our precipitate? It's the hydroxide. So this is gone. We have none of it left. It's all tied up in our precipitate. Okay, so what about these other three ions? Well, notice potassium is the same before and after. It is spectator. Nitrate is the same before and after. It too, these are both spectator ions. So that means nothing happened to them. However many moles of it we started with, we still have that in the solution. Nothing happened to them. They're not tied up in this aluminum hydroxide precipitate. So that'll be easy to get the concentration of. So we'll do that last. But let's look at this aluminum plus 3 ion. It came from the excess reactant. That means the excess reactant, some of it reacted to form aluminum hydroxide, but not all of it. So after the reaction stopped, there's still some of it left in the solution. What part of this aluminum nitrate reacted to form our precipitate? The aluminum did. Nitrate is spectator. Remember that. Nitrate is spectator. It's still there. It didn't react. But the aluminum, some of it did react to form precipitate. So we got to figure that out. That's where the first question asked you how many moles of excess ion is left in the solution. Well, that's because some of it did react, but not all of it. So we're going to have to figure that out. All right, so how many moles of each of these ions did we start with? Let's go ahead and label that. Let's look at the aluminum. Now remember, this is before any reaction. If we started with 0.01 moles of aluminum nitrate, how many moles of aluminum would be in there? That would be, it's 1-to-1 ratio, right? So that would be 0.01 moles of aluminum plus 3. Okay, let me erase this. How many moles of nitrate did we start with? Well, look up here. For every 1 mole of aluminum nitrate, we have 3 moles of nitrate ion. So if we start with 0.01 moles of nitrate, of aluminum nitrate, we can figure real quick 0.01 moles of aluminum nitrate okay, for every 1 mole of aluminum nitrate, we have 3 moles of nitrate ion. So we multiply that. And that gives us 0.03 moles of nitrate ion in solution. So I'm going to write that up here. So we start with 0.03 moles of nitrate. Okay, doing the same thing for potassium. Okay, for this potassium, well, we started with 0.02 moles of KOH. So how many moles of K plus are in 0.02 moles of KOH? It's 1-to-1 ratio, 0.02. And then, as I said, hydroxide, that's from the limiting reactant. That is the ion that got tied up into our precipitate. It's gone. All of it is in the solid, in the precipitate. So these are the ions that we've got to get the concentrations of. Now, as I said, let's save the easy ones, the spectators, for last. Let's deal with the ion that did react a little bit. That is the aluminum. Okay, the first bonus question asks moles of excess ion remaining in solution. Oops, sorry about that. Okay, well, what do we need to know? We need to take our moles of given excess ion, subtract moles of excess ion reacted. And that would give us moles of excess ion left over in the solution. We know how much excess was given. We just calculated it right there. But we do not know how much of it reacted. Okay, so remember, anytime you want to find out how much of something reacts or produced, you got to use your limiting reactant. So what we're going to do, we're going to take this given amount of limiting reactant and we're going to convert it to the excess. And that'll tell us how much excess reacted. So I'm going to do that down here at the bottom. Okay, so we had 0.02 moles of KOH, our limiting reactant. So we're going to change moles of KOH to moles of aluminum nitrate. And we get that mole ratio from the balanced equation. It's a 1 for the aluminum nitrate, a 3 for the KOH. But we need this in aluminum ions. Aluminum ions are what's left in the solution, not aluminum nitrate. Nitrate did not react. It's spectator. So I'm going to go one step further, and I'm going to change moles of aluminum nitrate to moles of aluminum ion. This is composition stoic. For every 1 mole of AlNO33, how many moles of aluminum is in there? 1. You see the subscript right there is 1, and that means 1 mole of aluminum ion. Okay, so we punch this in the calculator, and we get 0.00667 to 3/6. That's how many moles of aluminum ion reacted. That's how many moles of aluminum ion is tied up in this precipitate. So this number goes here. so we do this subtraction, 0.01 minus 0.00667, and we have 0.00333 moles of aluminum ion reacted. So that is the first bonus question for your reaction. Silver nitrate, you would have to apply to silver nitrate and sodium chloride. But that's how you find the first bonus. You probably would want to pause the video at this moment and go back through this again, because this is the hardest part of the bonus, is figuring out how many moles of excess ion are left in the solution. Okay, so once you get that down, the next question is, what's the concentration? Next question. What's the concentration of that excess ion in the solution? Remember, concentration is not moles. It is moles per liters of solution. So we need to take that moles and divide it by the total volume. Okay, this is aluminum for this example. So we want the concentration of aluminum. Remember, square brackets indicates concentration. So we're going to take moles of aluminum ion and divide it by total volume in liters. So we have 0.00667 moles of aluminum. Now we got to get the total volume. So we need to go back to our given. And I erased it. Okay, let me just put it back on here again. Okay, not a big deal. We had given, okay, we got the speaker, and we're pouring into the beaker 0.05 liters of aluminum nitrate, and we're pouring in 200 milliliters or 0.2 liters of the KOH. So what would be the total volume? You add these two together, and we have a total volume of 0.25 liters. This plus this. So we come over here and we put that total volume in the denominator. And that gives us the concentration of our excess ion remaining in solution. Take top divided by bottom, this divided by this, and we get 0.0133 molar aluminum ion remain in solution. Okay, that is the second bonus question, or you would have to apply it to your reaction. Finally, the third bonus question wants to know the concentration of our spectator ions. That's easy. That's the easiest part of this stuff. Okay, so what were our spectator ions? Go back up here. And remember, that's why I like having the ionic equation, because that way you can see at a glance. Our spectator was potassium. See it over here? Did not change. Nitrate did not change. Those are our spectator ions. Nothing happened to them. They're still there. So whatever amount we started with, that's how many moles we still have. So we started with 0.03 moles of nitrate. We still have 0.03 moles of nitrate in the beaker. So concentration of nitrate we've got 0.03 moles divided by our total volume, 0.25 liters, and we get an answer 0.120 molar nitrate ion. See how easy that was? Okay, our other spectator was the potassium ion. So the concentration of that. Okay, let's go back and inspect. We started out with 0.02 moles of potassium ion given. It did not react. It's still there. We still have 0.02 moles of potassium ion. Divide that by the total volume. And we get 0.08 molar potassium. So these two would represent what you have to do for bonus number 3. Now, bonus number 4 has to do with that other question, but I went ahead and typed it on the bonus page, what information you need to know, that you've got 3 flasks. They have different gases in them, and you are being asked a question about the behavior of those 3 gases. They are at STP. Each one has a volume of 1 liter. Everything you need to know for it is there on the problem. So hopefully this video will help you guys to be able to master this type of work. It is quite intensive, quite a bit of work with precipitation reaction story. You will see it in Gen Chem, and you will see it again if you go on to take analytical chemistry, which is called quantitative analysis at ASU. So very good skill, and it really helps if you just take it and break it down into little bitty problems. You know, this big, massive thing is more manageable if you just think about one thing at a time. Very good problem-solving skill for anything that you do in college. So, good luck, and I will see you guys in the morning. Have a good night.